So here's a graph of force times distance that I did as an example. There is a data point, here's another data point, and then the rest of the data points are the blue dots. I've then drawn, using a ruler, the best fit line, straight line to go through there. It should actually start at the 0. Then what we need to do is to get the area underneath the curve. So for the first distance, my first data point, I need to get this area right there. And that looks like a triangular shape. So I'm going to use the equation for the area of a triangle, which is 1/2 the base of the triangle times the height. So first, this first area, it's going to be 1/2, 1/2 times the base, which is 0.05, that's 5 centimeters, or 0.05 meters. And then I'm going to multiply that by the height, which goes up to here with the triangle, is actually at 5. So on the calculator, taking 1/0.05 and then multiplying by 5, this gives us a number of 1.125 joules, because we're taking newtons times meters. So that equals the work, but it is also the same as the elastic potential energy, or what we call the spring potential energy. So then you can record that in your data table. So now you need to go to your next distance that you applied a force to the elastic string, which for me was 10 centimeters or 0.1 meter. So I'm going to start here, and now I need this entire area plus this, because I have to go back to 0. So this whole section, which is now a larger triangle, so using 1/2 base times height, taking 1/2, the base is now 0.1 meter. Let me change color. That's not going to show up very well there. 0.1. And then we're going to multiply that by the height, which should be the 10. So multiply that by 10. So 1/2 of 0.1 is 0.05, and we're multiplying that by 10, so we get 5. And again, the unit is joules, and that equals the work, which is the same as the potential energy due to the elastic or the spring. So you just keep making your way up the triangle, and I'll draw one more in here for you. Let's use pink. So the next one would have to go to my next data point, which is at the 0.15, so I would need this entire triangular area. So keep working your way up until you get all the way to this largest triangle.